So what we're going to do now is called synthetic substitution, but what we're going to do is we're going to start with what we should already know. And so if I have this function right here, and I have the 4 that I'm going to substitute in, so I have f of 4, f of 4, and I'm going to substitute that in. That equals 3 times 4 to the 4th power minus 2 to the 4 to the 3rd power plus 5 times 4 plus 2. And if I do the math of this, this will be 768 minus 128 plus 20 plus 2. And it'll end up as a 662. So f of 4 is 662. Well, what I'm going to do now is do that same problem using what's called the remainder theorem. And I'm going to use synthetic division to do that. So I'm going to go ahead and create my box. The nice part about this is that the number they give you, we don't have to change. That's a 4. But what we do have to account for is every exponent. So if I have x to the 4th power and we have a 3 in front of it, and x to the 3rd power, I have a negative 2. I also have to put something in the whole to place value of x to the 2nd power, which is 0 because there's no x second. X to the 1st power is a 5, and then we have a 2. So we just have to make sure we account for all exponents. Now we just do our synthetic division. So if I drop my 3 down, and then 4 times 3, which is 12, and then add 4 times 10, which is 40, add 40 plus 0 is 40. 4 times 40 is 160, and add. And then 4 times 165, which is 660, and then add, I get 662. This last number is the remainder. And in this case, the remainder actually is the same thing as if we did a direct substitution. So if we use synthetic division, we can actually get the answer to a problem, or we can substitute. So we've done this part, and now we can use our synthetic division also to get our answer. All right, what we're going to do is use another theorem called the factor theorem, which means if we have a problem that can be, that is a factor, or German factor, then we can divide this into it and get a remainder of 0. So if I take this problem and set it up in synthetic, so I take my negative 5, but I change it to a 5, and I set up synthetic. Once again, we want to account for all exponents. So x cubed is a 1, x squared is a negative 7, x is a 7, and then x0 is 15. So all the numbers are there. So I drop down my first number, and then I go my multiplication, which is 5, and I add, then I multiply, then I add, and then I multiply. Oop, that's a negative 3. And then I multiply, I get negative 15, I get 0. So when you get a remainder of 0, it could be an answer like in the previous problem, but this means it's also a factor. So this problem, if I put my letters back in, x squared minus 2x minus 3 is a factor of this problem when I also use it with my other factor, which is x minus 5. So if you get a remainder of 0, x minus 5 is a factor, and what you get when you divide is the other factor. Now this problem right here, and I'm going to go ahead and use another color here, this problem can also be factored. And so this is a trinomial. So if I go, put two numbers multiply to give me a negative 3 and add up to negative 2, x minus 3 and x plus 1, do that. And so I can factor that problem, and then we still have our x minus 5. And so now I have 3 factors. If I were to multiply all this up, I would end up with what I started with. That's what a factor is. So when it asks for find the remaining factors of the polynomial, this would be our answer. So we're going to do the same thing we just got done doing. We want to determine, is x minus 2 a factor of this? That means, does it divide in this evenly? So I'm going to do my synthetic division. And I have a x cubed gives me the 1, x squared is a negative 7, x is 4, and then we have a 12. And so I drop down the first number, so there's my 1. 2 times 1 is 2. I add, then I multiply, and then I add negative 6, and then multiply. And if I get 0 as this last number, then x minus 2 is a factor. And then this other part, if I put in is also a factor. So x minus 2 is a factor, so yes it is, and this trinomial is a factor, but the trinomial can be factored. So once again, I want to go through the process of what two numbers multiply to give me negative 6, which would be a negative 6, and add up to a 5, which would be a positive 1. And so what I end up with is x minus 6, x plus 1, and x minus 2 are my all factors.